Welcome to the fourth tutorial for RUSLE2. In this tutorial, I will describe how to estimate soil loss along more complex shaped hill slopes. We will do this on the same Aurora Research Station field site that we used for tutorials 2 and 3. Up to this point, we have estimated soil loss along a simple, uniform, or straight hill slope. However, hill slopes are typically more complex in shape, such as a convex and concave hill slope. A published article called Measuring Field Slopes, available for download from the Ministry of Agriculture, Food and Rural Affairs website, describes these different slope types in more detail. The Omafra segmented slope screen template in RUSLE2 allows you to estimate the soil erosion along complex hill slope shapes. Please press continue in the bottom right-hand corner to advance to the next slide. To open this template, close all windows in RUSLE2. In the lower right-hand corner, right-click on the Omafra basic screen and select Load. Then, choose the Omafra segmented slope template from the list of options. Next, I will open the profile used in previous tutorials called Tutorial Example. You can see that as a result of switching templates, the profile layout has changed significantly. We now see a graphic showing the hill slope. At the bottom, we see a series of tabs where we can enter hill slope details. Click on the Slope Segments tab. This displays a table showing the different slope segments along the field's representative hill slope. We can add more slope segments by clicking on the plus sign at the top left of the table. Each time you add a new slope segment, RUSLE2 will ask if you want to keep the overall slope length the same. The slope length is 300 feet in our example. I will click Yes, because I assume the overall slope length remains constant. Let us assume that the entire hill slope has a convex shape. We can describe a convex shaped hill slope as being a series of straight slope segments. For this example, we will represent this convex slope as a series of 3 different straight slope segments. Beginning at the top of the hill slope, enter the first segment's length as 50 feet with a 1% slope. Enter the second segment as 150 feet with a 4.5% slope. Enter the last segment as 100 feet with a 1.7% slope. You will notice that the shape of the slope graphic at the top changes as you enter in these values. You have now described a convex shaped slope in RUSLE2. At the bottom of the profile window, take a look at the erosion rate estimate for this new profile. For my example, the average erosion rate is 2.2 tons per acre per year along the slope, but the sediment delivery is only 1.6 tons per acre per year. The slope segments table describes how each slope segment affects the overall average erosion and sediment delivery rate. For instance, the table shows that the middle segment actually experiences the highest soil loss at 4 tons per acre per year. The lower slope segment gains soil from the upper slopes as eroded soil from the upper sections is deposited on it. The result is a slightly lower amount of soil leaving the bottom of the hill slope than what moved along it. Thank you for watching Module 4 of the RUSLE2 tutorial series. You should now be able to estimate the erosion rates occurring along more complex hill slope shapes using RUSLE2. These tutorials are a great introduction to RUSLE2. However, there are many different field practices being used on Ontario farms that we will not illustrate in the tutorials. RUSLE2 has many different windows and features that can help describe the variety of cropping and management options you may use. Try experimenting with RUSLE2 to become familiar with its capabilities. Refer to the RUSLE2 Program User Guide from the United States Department of Agriculture's website for more help and information. You can find this by going to the USDA's website and searching RUSLE2 in the search bar. Click on the first link, scroll down, and click on the RUSLE2 Program User Guide. We hope that the information in these tutorials will help you compare the different soil health benefits of alternative management practices. If you have any questions as you apply RUSLE2 for Ontario, contact the Agricultural Information Contact Centre toll-free at 1-877-424-1300 or by email at ag.info.omafra@ontario.ca, and they will connect you with a technical specialist.